Hello, dear aspirants. My name is Aditya Amlan Panda, your mentor, and I am here to discuss with you the question on definite integral which we had posted in the community. So, this is the question, and you would have ample methods of solving it, directly expanding it, or using some properties of definite integral. पर क्या सभी चीजें properties से उतनी आसान होती हैं? Or is this question something different than what we have done before? Have you ever used graphs for calculating definite integrals? So before going into those things, चलो आपके साथ कोई normal बातें discuss की जाए. The most important application of definite integration is that it is used to find the area under the curve. Consider this curve, that is y is equal to fx. ये वाली जो area आप देख रहे हैं, this area can never be calculated if you are not using integration. You can for sure use horizontal bars, vertical bars, but that will never provide you that accurate and information as integration would do. So all those would be summing up to integration itself. So let's use this similar graphical method to solve this question. So let me give you a glimpse of how to start with it. What do you understand from this graph? First thing is that this wavy line is the function y is equal to fx. Now this area, that is the area enclosed by the wavy line, and the x-axis is the area enclosed by the function and the x-axis, and can be calculated by the integration of f of x dx bounded by the limits b and a, the upper limit b and lower limit a. Now think it the other direction. What if we calculate the integration of x dy, or to simplify f inverse of x dx? अगर हम f of x dx को कैलकुलेट नहीं करके हम इसको f inverse of x dx कैलकुलेट करते हैं, तो वो बराबर होगा इंटीग्रेशन ऑफ x dy. तो नॉर्मल चीज जो इस ग्राफ में दिखाई दे रही है वो है ये कि f of a is equal to c, f of b is equivalent to d. Now, if we are calculating f inverse of x dx bounded by the limits c and d, then we can calculate the area between the graph and the y-axis, that is this area. Now just consider one thing, that these points O, Q, P, they're just points, they're not values. But A, B, C, D, they are values, but मैं उनको points की तरह भी use करूँगा. You can take them as capital A, capital B, but that would again make it too much of complicacy there. So I will take them as values, I will take them as points also. लेकिन O, Q, P को हम points की तरह ही मानेंगे, values की तरह नहीं. So now, if we are calculating the sum of f of x dx from b to a and f inverse of x dx from d to c, then what? Now you will see one thing, that this area plus this area, when both of them are added, there is a unique kind of shape. This shape is nothing but the shape of the larger rectangle from where the smaller rectangle has been removed. The larger rectangle, that is ODPB, and the smaller rectangle is OCQA. So ODPB is a larger rectangle from where the smaller rectangle OCQA has been removed. So how can we find the sum of these two? Is through the area of the rectangle ODPB minus the area of the rectangle OCQA. Proceeding further, OD into OB minus OC into OA. That is because the area of rectangle can be calculated by the product of the lengths of two adjacent sides. हम rectangle की area को ऐसे calculate कर सकते हैं length into breadth, जो कि उसके लेंथ ऑफ टू एडजेसेंट साइड्स उनकी प्रोडक्ट होती है। यहाँ पे वो है OD इंटू OB, और इस छोटी वाली रेक्टेंगल का एरिया है OC इंटू OA। बड़ी वाली का एरिया है OD इंटू OB, और छोटी वाली रेक्टेंगल का एरिया है OC इंटू OA। Now, as I said before, that I would be taking A, B, C, D as values as well as points. इधर तो आपने देखा कि मैंने उसको पॉइंट की तरह गिना है, पर यहाँ पे उसको वैल्यू की तरह गिनते हैं। चलो आप इस O को 0 ले लो, और ये जो B है, B into this length is D. So this length is B and this length is D. Similarly, this length is A, this length is C. So BD into AC. BD is the area of the larger rectangle, that is B into D, and AC is the area of the smaller rectangle, that is A into C. But what can we notice from here? B is the upper limit of the first function and D is the upper limit of the second function. Similarly, A is the lower limit of the first function and C is the lower limit of the second function. So can you notice one important thing, that it is just the difference between the product of the upper limit and lower limit? That is the product of upper limits minus the product of lower limits. Now, will this really simplify the equations? Yeah, this will definitely. You don't need to expand it. When you see this type of question where that is the sum of f of x and f inverse of x, जब इन दोनों का सम दिया गया हो fx और f inverse of x, और उनका एक इंटीग्रल कैलकुलेट करने के लिए आपसे कहा गया हो, तो उस केस में जैसे यहाँ पे है B से A, D से C, तो आप सिंपली ना अपर लिमिट्स को मल्टीप्लाई कर दीजिए और लोअर लिमिट्स को मल्टीप्लाई कर दीजिए अलग अलग से। जैसे यहाँ पे A और C को आप मल्टीप्लाई करेंगे, B और D को आप मल्टीप्लाई करेंगे और उनको सेपरेट कर देंगे, और फिर अपर लिमिट का जो प्रोडक्ट आपका निकलेगा B और BD, उससे लोअर लिमिट AC के प्रोडक्ट को सब्ट्रैक्ट कर देंगे और वो आपका आंसर दे देगा। दैट इज द डिफरेंस बिटवीन द लार्जर रेक्टेंगल and the difference between the area of this small rectangle. Now, this was the question, right? क्या आपको ऐसा दिख रहा है कि ये जो फंक्शन है उसका इनवर्स ये फंक्शन है? Can you see that by doing some little bit of changes here, we can make it the inverse of this? If you are not able to see, अगर आप देख नहीं पा रहे, then let's go through the general ways that we usually follow. जब हम किसी भी ऐसे वैल्यूज को एक ब्रैकेट वगैरह में कुछ देखते हैं, तो हम उसको क्या करते हैं? हम सिंपली इस जो ब्रैकेट को इसको एक सिंगल वेरिएबल मान लेते हैं। इसको वेरिएबल मानने के लिए वो करना क्या है? सब्स्टिट्यूशन। तो लेट्स सब्स्टिट्यूट x minus t, x minus 2 as t. Taking x minus 2 as t, you can get this kind of values. आपने देखा मैंने लिमिट्स में कुछ कुछ बदलाव किए हैं। That is x minus 2 is equal to t. When x is equal to 4, x minus 2 becomes 4 minus 2, that is equal to 2. When x is equal to 5 by 2, then x minus 2 becomes 5 by 2 minus 2, giving 1 by 2. And here it is t, dt. So you are getting, because x minus 2 as t, d of x minus 2 is equal to dx and d of t is equal to dt. So dx is equal to dt. Now one more thing, integrals do not depend on variable, right? So this can be t, this can be x, this can be y, this can be z, this can be a, this can be anything. This can be. This is the property of definite integration, right? If it is a definite integration, then never ever does the integral depend on the variable. So what I did is that I simply changed this t into x. Now you can see it is sine inverse of log x to the base 2 dx within the limits of 2 and 1 by 2. Now you can easily see that 2 to the power sine x is the inverse of sine inverse of log x to the base 2. ये दोनों functions एक दूसरे का आपको inverse नजर आएंगे. The both are inverse of each other. आप इसको calculate करके भी देख सकते हैं, जैसे कि y is equal to 2 to the power sine x, और आपको कैलकुलेट करना चाहिए भी, बिकॉज इस तरह के रिस्क एग्जाम में मत लीजिएगा. डू कैलकुलेट इट बिफोर कंक्लूडिंग दैट बोथ ऑफ देम आर इनवर्स ऑफ ईच अदर. सो हियर इट इज लाइक y is equal to 2 to the power sine x. Now taking log either sides to the base 2, here you would be ending up with sine x, here it would be log y to the base 2. Now taking sine inverse either sides, sine inverse of sine x is x, and here it is sine inverse of log y to the base 2. Now, since x is equal to sine inverse of log 2 log y to the base 2, f inverse of x equals sine inverse log x to the base 2. Now simply apply the conclusion we had found in the previous slide, that is the product of the upper limits minus the products of the lower limit. Simply subtract the products of lower limit from the products of upper limit. Now products of upper limit is 2 into pi by 2, and product of lower limits is half into minus pi by 2. Subtracting them, here it is pi and here it is minus of pi by 4. So pi minus of pi by 4 gives you the result 5 pi by 4. So finally, this is your answer, that is 5 pi by 4. And as you saw, we didn't have to do much experiments with the question. So if you will take the other method, that is expanding it or using some definite integration properties, no doubt you will end up getting the same answer. But don't you think you'd be wasting a whole lot of time? Don't you think that would make your work immensely tough? Like consider here, how many substitutions you have to put here? How many substitutions? So before solving any question in mathematics, do choose your approach. आप अपना अप्रोच सही तरीके से सिलेक्ट कीजिए, उसके बाद आप क्वेश्चन से आगे बढ़िए. अगर आप क्वेश्चन से आगे बढ़ जाते हैं और आप कोई भी नॉर्मल मेथड को लेके अगर आप सोचते हैं कि आपका आंसर सही आएगा, तो वो आपकी गलतफहमी है. मैं ये बात एक बार क्लियर कर देना चाहता हूँ. Always the approach is more important than the result or than the calculation. So do work upon your approach, do work upon your thinking skills, like how I can move forward in the question. So you'll get the PDF in the description, and do post your queries if you have any on this particular question. All your queries are earnestly welcomed. So thank you.